In today's notes, we are going to talk about the division of rational exponents. When dividing the same base, we can subtract their exponents. Make sure to keep exponents positive unless directions say otherwise. In our first example, we are going to be subtracting 7 1/3 and 7 2/3. So because 7 are the same base being divided, we can subtract. Now, I know that if I were to subtract 2/3 from 1/3, I'd get a negative exponent. I want to skip the negative exponent step by just subtracting the smaller exponent from the bigger. When I do that, that means I need to put a placeholder 1 in the numerator. And I now have 7 2/3 take away 1/3. We know from our fraction rules that when we have the same denominator, we can subtract the numerator. So this will become 1 over 7 1/3. This would be exponential form. If we wanted to write it in radical form, it would be 1 over the cubed root of 7. Because we can't have a radical in the denominator, we would want to rationalize this, but for these notes, I'm not going to do that right now. In example 2, because we have the same base, we are allowed to subtract, but we first need to convert to fractional exponents. So the numerator will become x to the 3/4, and the denominator will become x to the 2/8. At this point in time, I don't have the same denominator, so I'm going to change 4 into 8 by multiplying by 2, top and bottom. This will give me x to the 6/8 over x to the 2/8. Now because the bigger exponent is on the top, I'm going to subtract the bottom one from it. This gives us x to the 6/8 minus 2/8, which gives us x to the 4/8. 4/8 can also be written as x to the 1/2. In radical form, this would simply be the square root of x. In our next set of notes, we now have a coefficient in front of our variables. So before we start with the exponents, let's simplify our coefficients. 10 divided by 2 will give us 5. So now our new term is x to the 1/3 over x squared. Now we can take care of the exponents. I'm going to put a 1 in the denominator to make this a fraction. We don't have the same denominator, so I'm going to multiply 2 over 1 by 3 to give it the same denominator. So now it is 5x to the 1/3 over x to the 6/3. We know that 6/3 is bigger than 1/3, so we will bring this down to subtract. We are left with 5 in the numerator. We don't need the placeholder 1 because the 5 is there. And 5 times 1 would give us 5 anyways. 6/3 take away 1/3 gives us 5 to the x in 5/3. If we wanted to write this in radical form, it would be 5 to the, over the cubed root of x to the 5th. And again, we can't have radicals in our denominator, but we're not going to rationalize them right now. In our last example, we first need to distribute this exponent to the bottom and the top exponents. This goes back to our power of a power rule. So we will be left with x third over 1 times negative 1/4 over x negative 1 over 1, I'll make it a fraction, times negative 1/4. With multiplication, we multiply across, giving us x negative 3/4 over x positive 1/4. Negatives times a negative will give us a positive. So we know that negative 3/4 is smaller than 1/4. But because it's negative, we're going to do something that's a little tricky. So again, we'll bring this down, leaving us with x to the 1/4 minus negative 3/4. We know that two negatives are going to give us a positive, so we can rewrite this as x 1/4 plus 3/4. 3 plus 1 will give us x to the 4/4. And 4/4 can be written as 1. So my final answer will just be x.